Alright, welcome to lesson 1.08. Today we're going to be solving quadratic equations with real coefficients that have complex solutions. Okay, so go ahead and copy this question down along with the graph and the work and answer A and B in a full and complete sentence or sentences. And then we'll have a brief chat about it, but this will allow you to discover what it is that we're going to be working on today. All right, so hopefully you were able to go through and pinpoint the noteworthy aspect of this graph. Right, the key characteristics, as we remember them, are the roots, the vertex, and the y-intercept. Now, there's really nothing that special about the y-intercept. It's a value of 3. That's good to know, but nothing that noteworthy. The vertex is here, and it's a normal-looking vertex, nothing too special. But the roots are kind of noteworthy in that the roots are the x value, where on the x-axis, the y value is 0, or graphically, where the function intersects the x-axis. But if I notice here, this function is never intersecting the x-axis. So that's something that I notice about this graph. In part B, I want to know, how does this algebra that was done over here, how does this work to find the roots, prove this interesting thing that I noticed about my graph? So if I look through this work, and this work is done very nicely, notice that they're trying to find the roots. And so what you do when you're finding the roots, well, the roots are the x value that you get when you set the y value equal to 0. So what we're doing is we're setting the y value equal to 0 and solving for x. Really, we're just solving an equation that's set equal to 0. And so we go through and we can use the quadratic formula to solve for x. X will be equal to negative b plus or minus the square root of b squared, which is 9, minus 4 times 1 times 3, or 12, all divided by 2. Now, in this next step, what they did is they separated the denominator into both pieces of the numerator, which we've talked about previously. So you can write this again as negative 3 over 2 plus or minus square root of 9 minus 12 over 2. And so this is all correct, but why does this show me or prove to me that that looks the way it does? Well, if you were to go one more step, what would happen? You'd have x equals negative 3 over 2. We can leave it like that. That's negative 1.5 plus or minus. Now, inside the square root, I can simplify, and I'm going to end up with the square root of negative 3 over 2. Okay, well, what do we notice here? This is an imaginary number. In fact, what is its imaginary number? Well, if I simplify it, what I end up with is, remember, I can separate the 3 and the negative 1. So I will have the square root of 3 times negative 1, which is equal to the square root of 3 times the square root of negative 1. And the square root of negative 1 is just I. So I'm left with the square root of 3 times I. And if you plug the square root of 3 into your calculator, you'd find it's 1.7 or something like that. But we can just write it in its precise form as the square root of 3, just like that. And so when I finish solving, what I get is that the x value that makes the y value 0 should be negative 3 over 2 plus or minus the square root of 3 over 2 times I. And this is an imaginary number. So if I have an imaginary number as my x value, do you see that imaginary number anywhere? This is all real numbers. Since this axis only consists of real numbers, it will be impossible for my function to intersect it anywhere, since the only value of x that will make this function 0, make the y value 0, is a complex value. All right, so I am very, very confident that at this point you have a really good idea of the process by which you can find the roots, in other words, solve a quadratic equation precisely, accurately, and efficiently. So go ahead and answer this problem Find the roots of the function f of x and explain what they mean about the graph of the function, of course. And as you're going along, what I want you to do is annotate your steps. In other words, create for yourself a protocol, a step-by-step process, just very much like we did when we wrote that perfect, beautiful sentence about finding the roots and explain what they mean. And what you'll want to do is kind of keep this always with you so that you'll know what it will look like and what you'll have to do to successfully solve quadratic equations. Once you've done that on your own, then I'll take you through mine, and you can make any changes to yours that you think make more sense, or you think mine is a little more efficient, or if you like yours better and you know it works, you can use that as well. What I should see, though, is that you've tried this on your own first and gone through, solved, and created your annotations. That's what the scholars who are doing best in this class are doing. They're showing that they've done it on their own and then made any changes on the right. And that's leading them to be very successful. So go ahead and try this on your own, and then we'll walk through it. Okay, so the first part of this question is actually the understanding portion. Find the roots of the function f of x. And when I read find the roots of the function f of x, immediately in my mind, I know what I'm doing is I'm setting f of x equal to 0, making that equation equal to 0, and then I'm going to solve for x. Okay, so immediately my understanding piece, which actually goes along with my planning piece, is done. And so now I'm just going to go through the work, and what I'll show you is in my work I have each of these pieces as an integral part. Okay, so let's go ahead and begin. So the first thing that I need to do is I'm going to set f of x equal to 0. Right? This says that I'm making my y value 0, I'm going to solve for the x value. So what that means is that I now have 4x squared minus 6x plus 3 is equal to 0. And if at any point you realize, hey, I forgot to do that, or let me go back, I can redo that, you should. Doing it on your own will make you that much better the next time you try to tackle one of these problems. So at this point, I need to solve for x. So how am I going to do that? Well, if I'm going to solve for x, I need to isolate x. And luckily, if I have a quadratic set equal to 0, a quadratic equation where it's set equal to 0, I can use the quadratic formula. So solve for x using, and I'm going to abbreviate with QF for a quadratic formula. Now remember, the quadratic formula solves for x, that's the key word there. So I'm going to have x equals, it's hugely important to remember what it is you're actually doing. And I should remember that it's negative b, so I have 6 plus or minus the square root of b squared, which is 36, minus 4 times 3. 4 times 4 is 16, times 3 is going to be, we can do this in our head, 16 times 3, 10 times 3 is 30, 6 times 3 is 18, so 48. All divided by 2 times 4, which is 8. Okay, so at this point, what we have is a pretty simple process. We're going to continue solving for x until we have a simplified form. So this is a step that maybe you're not familiar with, but that you will notice from the work in the previous question that we did, and that is actually splitting up the numerator into the real part and the radical part, which is the part that could be imaginary. So that way, if it is imaginary, then we're okay because we've separated the real part already. And if you remember, this is negative b over 2a. That is the x value where the vertex occurs anyways. So splitting that off will really help us to visualize our function, to know the x value where the vertex occurs, and will help us understand the symmetry, because we'll have the vertex point plus or minus some value, which tells you that the roots are on either side of the vertex. Of course, with complex roots, we won't see them anyways, but that'll be okay. So we'll split that up, and we'll have 6/8 plus or minus the square root, and here I can go ahead and simplify that. 36 minus 48 is -12 divided by 8 again. And I can continue simplifying now, and the important thing here to notice is that I am going to evaluate the imaginary number. Okay. And now I can continue simplifying. 6/8 simplifies to 3/4 plus or minus. And if I have the square root of -12, go back to your notes if you need to refresh your memory on imaginary numbers. What I can do is I can rewrite the square root of a negative number as the square root of the positive version of that number times I. So what I end up with is the square root of 12 times I divided by 8. Okay? And now this is a perfectly fine answer. It shows that there are two solutions, right? The plus and the negative version, positive and the negative. So 3 plus this or 3 minus this, but both of them are going to be complex values. So these are both complex numbers. But I can do some further simplification, and I'll show you a couple ways to simplify. So one way that I can simplify is I can turn these into decimal form. So 3/4 would be 0.75, and I use my calculator, I could do the square root of 12 divided by 8, and it will be the square root of 12 over 8 times I. But there's another way that I can do it, and I'll show you this other way first. This is where I simplify the fraction, so I still have 3/4 plus or minus. Now, I'm going to show you a little bit of work off to the side. So if I have the square root of 12, that is equal to the square root of 4 times 3. And the reason I break it up like that is because 4, I know the square root of 4. So I can rewrite that as the square root of 4 times the square root of 3. And this is just 2. So this is really 2 times the square root of 3, and remember I had divided by 8. So now 2/8 is the same as 1/4, and I've simplified this to the square root of 3/4. Times I. Okay? So that would be a more nicely simplified version. And if I wanted, I could turn this into decimals as well. And so I could say this, or I could have x is equal to 0.75 plus or minus. And if you get the decimal approximation, you get 0.433 times I. And of course, you could separate it out. You could write both 0.75 plus this, or 0.75 minus this, the two different ones, or you can use the plus and the minus, so long as you are clear. Okay? And so these are the roots, and what will this mean about my graph? Well, what it will mean about the graph is that the graph will never intersect the x-axis, because the only values that make the function, the y value of the function, equal to 0 are complex values, and those don't exist on the x-axis. So go ahead and write out your own version of that. Make sure that you have these annotations here, because this is going to be your reference for when you go back and you are solving problems like this. Maybe you're just solving a quadratic equation, and you go back and you look and you realize I have to set it equal to 0, so you make sure that your equation is set equal to 0, and then you can follow through in this way. And that's going to be very important. So I'm going to give you one more to try on your own. give that your best effort, make sure your solution is correct, and then we will be able to take a look at it tomorrow. All right, go ahead and try these two problems, really the same problem, on your own. Make sure that you go all the way through with it. You have all the possible tools you need and understanding you need to solve this equation, so there should be no giving up whatsoever. And then make sure that you spend some time thinking about this question here and answering it in a full and complete sentence.